Hi, in this video, we will look at certain basic concepts of a mathematical tool called as derivatives so that you can understand the next derivation easily. So first of all, just remember that you write derivative as d by dx. So this is derivative. How do you read this? You read this as derivative of cos of input with respect to input, or you could say derivative of cos of x with respect to x. So how do you read this? Derivative of cos of input with respect to input, or derivative of cos of x with respect to x. So remember one thing, the input here is x and the x here and the x here should be the same. That is something you have to take care of for your basic formulas, that your input here x and your input x here is the same. So derivative of cos of input is sine of input minus sine of input. So I'm going to say derivative of cos of input is equal to minus sine of input. Now it is not necessary that the input is x. If the input is t out here, you will say d by dt of cos of t. So you would say d by dt of cos of t is equal to minus sine of t. So your input needs to be the same. That's the first question for derivatives. So remember, derivative of cos of input is equal to minus sine of input. So if I change the input here, if you see, I've written d by dt of cos t. Now my input is t. So I'm going to read this as derivative of cos of input. Now the formula for derivative of cos of input is minus sine of input. So I am going to first check my inputs are the same. Now since the inputs are the same, I am going to write minus sine of input. The input in this case is t. I told you why I am using the word input, because the input can be anything. It is not necessary that it is an x. So the first formula you should know for this chapter is derivative of cos of input is equal to minus sine of input. The input can be anything. In this case, the input is x. In this case, the input is t. But take care of one thing, that the input written here in front of cos and the input written in derivative is the same. So input written in front of cos and in front of derivative is the same. Second formula is derivative of sine of input. This was derivative of cos of input. The next formula is derivative of sine of input. So again, we need to check the input is the same. And in this case, your input is the same. So the formula for this is derivative of sine of input is equal to cos of input. So how would you learn this? Derivative of sine of input is equal to cos of input. So now I am changing my input to t. So again you will say derivative of sine of input is equal to cos of input. But you have to first check that your input is the same. So in this case your input is the same, and then you are writing this as cos of input. So two formulas, derivative of cos of input is equal to minus sine of input. Derivative of sine of input is equal to cos of input. Now the third formula is derivative of input. That's it. How do you read this? Derivative of input. But this input and this input should be the same. So derivative of input, the answer is 1. Remember. So any input you take, if I say derivative of input, the answer is 1. In this case, I'm going to say derivative of x. In this case, my input is x. I am not going to consider 6. 6 will remain as it is. So I will say this is, if I don't consider 6, I will say this is derivative of input. And I know the formula for derivative of x or derivative of input is 1. So my answer is going to be 6 kept as it is. Derivative of input, which in this case is x, is 1. So your answer turns out to be 6. Now, similarly, I could also have derivative of omega t. Now, what is given here at the bottom? T. What is given here? T. So, I am talking about derivative of t, or I am talking about derivative with respect to t. So, whenever I am talking about derivative with respect to t, and t is what? T is nothing but your input, because whatever is down in the derivative, that is your input. Now, in uniform circular motion, if you remember, in uniform circular motion, your omega or angular velocity is constant. So, if it is constant, I would say it's like a number 6. I again repeat, in uniform circular motion, I'm talking about the case of uniform circular motion, your omega or your angular speed is constant. If it is constant, I will consider it to be a number. So if I take it as a number, I will just say this is not supposed to be touched. So I will write omega as it is. Then I will get derivative of input, right? Can you see the input is t? And here what is remaining? T. So derivative of input, the answer to this is 1. Because whenever your input is, or whenever you talk about derivative of input, your answer is 1. So I will write omega into 1, which is nothing but omega. So that is your derivative of input, that's equal to omega into 1, which is equal to omega. Now, the next one is derivative of a constant. Now, what do you mean by the word constant? Constant basically means only number. It could be any number. I could have only 6. I could have only 10,000. I could have only 15,000. So derivative of only a number, the answer is always 0. Let's take an example to understand this. If I write derivative of 6 with respect to x, so this is your x, so your input is x. But since it's only 6, 6 is just a number. I don't have any variable with it. Can you see that? I don't have an x, y, anything written. I have only 6 written. So 6 is just a number. And if it is just a number, you call it a constant. And you remember derivative of a constant is 0. So your answer turns out to be 0. Similarly, if I am writing d by dx of 81,000. Now if you carefully see, this is 81,000. There is no x, y, z variable. So derivative of 81,000 is again going to be just a number. So derivative of just a number is going to be what? 0. So your answer turns out to be again 0. Similarly, you have a next case. Now if you see the previous cases, in this case, if you see, we carefully said the input here and the input here was the same. So that was the case when I said my input is the same. Now I am going to talk about a case where this input is not same as this input. We'll understand this in a moment, but understand that previously we talked about 3 formulas: derivative of cos of input, derivative of sine of input, derivative of input, and derivative of constant. We did 4 formulas. But in all the formulas, wherever your input was there, this input was similar to the input of derivative. Now we will consider a case where your input is not same. So let's consider your case when the input is something different. So when your input is something different, here if you say I've written d by dx of sine. Now obviously I know derivative of sine of input is cos of input. Right? Derivative of sine of input is cos of input. So I don't know what is my input right now. With respect to derivative, my input is x. But what is there with sine, I don't know. So understand, I have written 2x with sine. So with sine, my input is 2x. But my input should have been x. Therefore, I say my input is something different. I repeat, with sine, my input is 2x, which should have been x. So in case my input is something else and not x, I say when my input is something different. Now in that case, I know derivative of sine of input is cos of input. So I will just say derivative of sine of input is cos. Now what is my input here? My input is 2x. So first I will write it is cos of input. So cos of input basically means cos of 2x. I again repeat. derivative of sine of input is nothing but cos of input. So sine ke liye the input was 2x, therefore for cos also I am putting 2x. But this is not the end. I am going to multiply this with the derivative of the input. Now what is the input here? 2x. So I am going to multiply this with derivative of 2x. Remember, this step is extra. So if your input of derivative and the function is not the same, for example, here you have 2x, here you have x. So you use the formula normally, you will say derivative of sine of input is equal to cos of input. But you have to multiply this new input's derivative also. So you have to multiply the new input derivative. So you will say d by dx of 2x. Now, how do you solve this? Again, you know this 2 is a number. Nothing to be taken care of, right? So this 2 will be kept as it is. And then this x and this x is the same. So this becomes like derivative of input, right? Because this 2 is a number, we will not take care of that 2 number. And I will say this is like derivative of input. And I know derivative of input is 1. So this 2 is going to be kept as it is. The derivative of input is 1. Now 2 into 1 is 2. So I'm going to just multiply this 2 to this term, cos of 2x. So the final answer I'm going to get is 2 cos of 2x. This entire derivative was 2. Why? Because this 2 is a number or a coefficient which we are not supposed to consider in derivatives. So we know derivative of input or derivative of x is 1. So I get 2 cos of 2x because 2 into 1 is 2 and this 2 is going to be multiplied to this cos of 2x. Now understand the next derivative. Here also if you see I have written derivative of cos of input. But the input of cos and the input of derivative is different. So the input of cos is 2x and the input of derivative is x. So input of cos and input of derivative is different. So whenever your input of cos and your input of derivative is different, the first step remains the same. You know derivative of cos of input is minus sine of input. So derivative of cos of input is minus sine of input. My input here is 2x. So I will write minus sine of input which is 2x. That's my first point. But I don't have to stop here. I have to multiply this by the derivative of the input. Again, what is the new input? 2x. So I have to multiply this by the derivative of 2x. So when I multiply this by the derivative of 2x, now 2 into x derivative is what? Very simple, we'll solve it. This 2 is a number that is not going to be taken or that's not going to be considered in derivatives. So this x is going to be considered. X is like the input, derivative of input is 1. So I'm going to say this is 2 into 1, which is nothing but 2. So this 2 now is going to be multiplied to this entire term minus sine of 2x. So I will get the answer as minus 2 sine of 2x. It's very easy to understand. This is when your input is something different, which means you have something different here and you have something different here. You have a 2x here and you have an x here. You have a 6x here and you have an x here. Now listen, I'm not going into the depth of derivatives. I'm only teaching you that part of derivative which is going to be useful to understand the following derivation. Now, in a similar example, let's understand derivative of cos of input. Now, in this case, the input is omega t. Can you see here I have a t as an input? Here also I have a t as an input. So now your input is omega t. Can you see you have a t here and you have a t here? You know derivative of cos of input is minus sine of input. So the first thing is going to be I'm going to write minus sine. Then I'm going to write the input. The input here is what? Omega t. So derivative of cos of input is equal to minus sine of input. I think that is very clear. Now I'm not going to stop here because my input was something different. I have to take the derivative of the input. So what is the input here? Omega t. So I'm going to multiply this by derivative of omega t. Now if you remember in uniform circular motion, omega, that is your angular velocity, is constant, right? Angular speed rather is constant. Therefore, you will consider this omega to be a number so that it becomes just t. and you know derivative of t is like derivative of input, and you know that derivative of input is going to be 1. So you will write this as omega into 1, which is nothing but omega. So you will multiply omega with this entire term minus sine omega t. So your answer is going to be minus omega sine omega t. That's the derivative of cos of omega t. Now we know this velocity is equal to displacement upon time. So if you call your displacement to be x and you call your time to be t, and I am interested in talking about instantaneous velocity. If you remember the fundamental videos, I had told you in that case that whenever you talk about the word instantaneous velocity, instantaneous means at that instant, and for representing instantaneous we use derivative. So we will write d of x by d of t. This represents very small. So what do you mean by dx by dt? Can I say x is displacement? So this is read as derivative of displacement with respect to time. So how will you learn this formula? You will say velocity is equal to derivative of displacement with respect to time. In a similar manner, I have acceleration, which is nothing but change in velocity upon time. So if I call the velocity v and the derivative t, and I am interested in instantaneous acceleration, so I am going to use dv here and I am going to use a dt here. So I will say acceleration is equal to d by dt of v, which in words is said acceleration is derivative of velocity with respect to time. So how do you read acceleration? It is derivative of velocity with respect to time. So your input is what? Time. Remember, whether it is velocity or it is acceleration, your input is time. Now understand the last and the most important thing. Let's say you know this, right? V is equal to r omega. Now r and omega, if both of them are variables, they are not numbers. In the previous case I had told you that in uniform circular motion omega is constant, right? But now I am just taking up a case where I am saying whether it is r or omega, both are variables. Now if you remember any algebraic equation, you would say like 6x plus 2 is equal to 10. So that x is your variable. 6x plus 2 equal to 10. What I am saying, 6x plus 2 equal to 10, x is your variable. 6 is your coefficient. You remember fundamentals of algebra. I am saying r and omega both are variables. So how do you take this derivative? So let's say if I want to take derivatives of two variables which are multiplied together. So I am taking derivatives of two variables which are multiplied together. I am going to say differentiate with respect to t. So if I differentiate with respect to t, in the left hand side I will get dv by dt. In the right hand side I will get d by dt of multiplication of two variables, that is r omega. Now I am going to teach you how do you solve this. Now r is your first term, omega is your second term. Remember, r is your first term, in this case omega is your second term. So keep your first term as it is. Take the derivative of the second term. I am saying keep your first term as it is. Take the derivative of the second term. So I get d omega by dt. Then I plus. Then keep your second term as it is. Now what is your second term? Omega. You keep your omega as it is. Take the derivative of the first term. So what is your first term? dr by dt. I again repeat, keep your first term as it is. Take the derivative of the second term. Keep your second term as it is. Take the derivative of the first term. So you have r d omega by dt plus omega dr by dt. Now let's take an example to understand this. You have a velocity which is given to you as sine t and cos t. Now sine t is your first term, cos t is your second term. And the rule says keep your first term as it is. So you will keep, when you differentiate with respect to t, the rule says the left hand side will become dv by dt. The right hand side, keep your first term as it is. So what is your first term? Sine t, keep it as it is. Into derivative of second term. Now what is derivative of second term? d by dt of cos t, and derivative of cos of input is minus sine of input. So I have taken the derivative of second term. I again say derivative of cos of input is minus sine of input. Now I will keep the second term as it is. Second term is cos t. Take the derivative of the first term. Derivative of sine t is nothing but cos t. So I will write cos t here. I again say this is sine t, the first term kept as it is. Take the derivative of the second term. Derivative of cos of input is minus sine of input. Plus as it is. Keep your second term as it is, cos t. Take your derivative of the first term. So derivative of sine of t or sine of input is cos of input. What is sine into sine? Sine square. So I get minus sine square t. Plus will remain as it is. Cos into cos is cos square. You get plus cos square t. So this is called as the u into v rule. What this is called? U into v rule. Keep the first term as it is. Take the derivative of the second term. Plus keep the second term as it is. Take the derivative of the first term. Now these are the basics which you are required to know of derivatives before solving the next derivation. We will have a recap. How do you split a vector into its components? So we should know this. Let's take an axis. Now the horizontal axis is called as the x1. The vertical axis is called as the y1. And the axis which is coming towards you is called as the z-axis. Now if you want to know only the direction of x-axis, listen to this carefully. If you are intended in finding out only the direction of x-axis, you will denote it by using I cap. So I cap is a unit vector. A unit vector's magnitude is 1. So it only gives you the direction of an axis. I cap is a unit vector which gives you a direction of x-axis because the magnitude is 1. Therefore, it is only going to give you the direction. Similarly, the direction of y-axis is given by a unit vector called as j cap. And the direction of z-axis is given by a unit vector called as k cap. So you have, if you want to denote the direction of x-axis, you use I cap, y-axis you use j cap, z-axis you use k cap. So let's say you have a force like this. Now you want to split this force into components. Now what I mean by this is that if you have one big force, you want to find out if this force is of 100 Newton. How many newtons of the force are going to be along the x-axis? How many newtons of the force are going to be along the y-axis? How many newtons of the force are going to be along the z-axis? So you are splitting the force into parts. That is called as splitting the vector into components. So Fx is that part of the force which is acting along the x-axis. Fy is that part of the force which is acting along the y-axis. And Fz is that part of the force which is acting along the z-axis. So you are going to write your F bar and you are going to split this into Fx bar plus Fy bar plus Fz bar. So in this case, you have taken a vector and all the components of the force are also in terms of vectors. So F bar is a vector, Fx bar is a vector, Fy bar is a vector, Fz bar is a vector. Now, if I am interested in splitting this vector, now what I mean by splitting this vector, I am going to write this vector in terms of magnitude and direction. Now I know if it's along the x-axis, the direction is I cap. So this is splitting the magnitude and direction of the vector. I write Fx bar as Fx I cap. Now what is this Fx? This Fx is the magnitude of the force along the x direction. How do I know it's the x direction? Because I've written an I cap here. I know I cap is something which is used for direction of x-axis. Similarly, if I want to split this Fy into magnitude and direction, I will write Fy j cap. Now what do you mean by Fy j cap? Fy is the magnitude of force along y direction. How do I know this is y direction? Because I've written j cap. J cap is along the y axis. Similarly for Fz, I am going to write Fz k cap. Fz is the magnitude of the force along z direction. How do I know it's the z direction? Because I am using k cap. So I will write F bar is equal to Fx I cap plus Fy j cap plus Fz k cap. So while splitting the vector into components, carefully noticed I have written the magnitude separately and I've written the directions as I cap, j cap and k cap. Kindly make a note of this. Separate magnitudes and the direction to be I cap, j cap and k cap.